How's it going, guys? Today in this video, we're going to be going over Module 3.1, Day 1. So we'll start with this warm-up. It's a little review from Module 2. So go ahead and pause the video and try it if you haven't. But I'm going to go ahead and get started. So remember, when we're dealing with absolute values, we're trying to solve it. We need to isolate it first. So we're adding 8 to both sides. So we're left with -5 times the absolute value of x plus 7 is going to be less than 17 plus 8, which is 25. And then after that, I'm going to divide each side by -5 to isolate the absolute value. And anytime you divide or multiply by a negative number with inequalities, you have to flip the sign. So you get the absolute value of x plus 7 is greater than -5. And now we're left with an absolute value being greater than a negative number. No matter what x value I plug in, I'm going to get a positive or a 0 number. And every number from 0 to any number that's 0 or positive will always be greater than -5. So no matter what x value I plug in, I'm going to get a 0 and a positive number, which will always be greater than -5. So this is all real numbers. And when it comes to graphing the line, just shade the whole thing. It goes on forever because it's every single real x value. All right. So let's go ahead and get started. So today we're starting Module 3.1, like I said, and we're going to be dealing. It's going to be very similar to Module 2 in a way, where we're going to be studying a new function and seeing how we can play with it with our parameters of a, b, h, and k. But with quadratics, we don't really deal with b as much as we do with maybe the absolute values like we saw in the previous module. So in this case, our vertex form of a quadratic is a very important form for you to know. You do need to know what a vertex form of a quadratic function is. That's going to be very similar to the equations we've been seeing all along. F of x equals a, our a is on the outside, times x minus h squared plus k. We do not have our b here because our b, like I said, isn't as important with quadratics. You could see it, so don't think you won't see it. You could, but in most cases, you're probably not going to see it. All right, our vertex is still going to be hk. The axis of symmetry, remember the axis of symmetry is the line that cuts the graph in half. The vertex is in the middle of the whole function of the whole graph. So that means the axis of symmetry is going to be the line that goes through the vertex. So it's going to be x equals h, the line that goes through the vertex. So when a equals 0, sorry, when a is greater than 0, or when it opens up, we can see what that looks like right here on the side. That right there is what a quadratic function is going to look like when it's opening up, more or less. We can see that f of x has a minimum value of k. That vertex is our minimum value. It's the smallest point of the whole graph. And since it's the smallest point of the whole graph, its y value is the minimum value of k. The domain of f of x is all real numbers. However you want to write it, negative infinity to positive infinity. X is a element of all real numbers, whatever you want to write it. As long as you're saying it's all real numbers, it's okay. That's what the domain is. The range, we can see on this graph that our smallest y value is k. It is going up forever. So we go from our smallest y value of k to our biggest, which is positive infinity. So the range is from k to positive infinity. Now, when it comes to decreasing and increasing, that's where it gets a little tricky, and that's where it's really good to have a picture of a graph. So if you don't have one, and you're trying to decide if it's, where it's decreasing and increasing on, it's good to draw a little rough graph, a little rough sketch, sorry, of a graph to see what it looks like. So on this over here, I see that from left to right, because remember, we read graphs left to right, that if I start from the left side of the graph and I start moving down or moving to the right, I'm decreasing until I hit this vertex. So in other words, I'm decreasing, going from left to right, I'm decreasing from negative infinity all the way to my x value of h. We talk about decreasing and increasing by values of x. So we're decreasing from negative infinity all the way up to h. And as soon as I hit this h value, I start increasing again as I go to the right. So I'm increasing from h to positive infinity. So from negative infinity all the way to the x value of h, I'm decreasing. And as soon as I hit that vertex, which is a turning point, I start going back up. I'm increasing from h, the x value of h, to infinity. Now, when it comes to the function when a is negative, or when a is less than 0, or when it's opening down, it's going to be a little different. So we have our graph of what that's going to look like on the right here as well. It's always good to have a little rough sketch of a graph so you can kind of see the properties of it. So here, that didn't press that one, but whatever. We see f of x has a maximum value of k. We see our vertex is our biggest point. That's our maximum point. And everything on the graph is below it. So that's our biggest point. So if that's our biggest point, we can see that our range that I opened up by accident goes from negative infinity up to that y value of k. Right, k is our biggest y value, and it goes down forever. So we write our range from least to greatest. So we go from negative infinity up to a positive k. Our domain is still all real numbers. Every single real x value I plug in will give me a value on the quadratic. So it's all real numbers. For decreasing and increasing, again, remember we always read graphs left to right. So if I start in the far left of this graph, all the way to the left, it's negative infinity, and I keep going to the right, eventually I start getting to this point right here, where I'm increasing all the way up to this hk point right here, right? And then I start decreasing right after that. So from the left all the way up to this hk point, or up to that h, I'm increasing. So from negative infinity all the way up to the x value of h, I'm increasing. And as soon as I hit this vertex right here, and I start going to the right of it, I start going down and I'm decreasing. So I'm decreasing from h to positive infinity. So it's good to have a graph so you don't have to memorize where exactly it's increasing or decreasing on, depending on what value a you have. It's good to sketch a graph to see exactly what's happening. All right. So now we're going to talk about the transformations of this function. So this, the same transformations apply here as they did in the previous sections. If a is negative, it's still going to be a vertical a vertical reflection over the x-axis. The absolute value of a is greater than 1. So basically something like 1, 1.1, 1.2, 2, 3, 4, 5, stuff like that. That's going to get a vertical stretch. Anything bigger than any absolute value of a bigger than 1 is a vertical stretch. And anytime you have an absolute value of a between 0 and 1, so these are kind of like the fractions that are less than 1, like 1/2, 2/3, negative 1/2, negative 2/3, stuff like that, you're going to get a vertical compression. Our k is still our vertical shifts up and down. Our h's are still our horizontal shifts left and right. And like I said, we really don't deal with b all too often with quadratics. It could pop up, but chances are it's not going to. It's just not something. It's not very useful for quadratics, so we don't really use it. So now we have these two examples. Honestly, you should be able to do this yourself. By now, we've talked a lot about transformations. So if you want to pause the video and try it, go ahead and do it. I'm going to go ahead and get started. So here I see my a is 1/2. My b is 1. I don't have a b. My h is 2, and my k is 7. So when a is 1/2, that tells me I have a vertical compression. When my b is 1, that tells me we're not doing anything. B is not there. We can scratch it out. When h is 2, we're going to the right by 2 units. And when k is 7, we go up by 7. All right. So on the second part right here, which is your turn, if you haven't paused the video to try it, I do encourage you to try it. So pause the video and just try to get what the transformations are, because you are going to be dealing with them all year round. So hopefully you paused it, you tried it. If not, I'm going to go ahead and get started anyway. So my a, I see is 3. So that means I have a vertical stretch. My h is a -4. Remember, it's in the form x minus h. So x minus -4 gives me that x plus 4. So my h is -4, which tells me to go to the left by 4. And lastly, my k is -5. That tells me to go down by 5. All right. So let's keep going. Now we're going to kind of what we're doing here is we're given a function, right? We're given a quadratic function in vertex form. That's important to know. This is in vertex form. What we're going to do is take it, and from just this equation, we're going to figure out pretty much all its properties. All right. So the very first thing we're asked is, what's this vertex? That's hk. So our vertex here is our h and our k. of 3, 5. Which way is open? That's from our A. We see our A is positive, so it's opening up. So that's what we put. It's opening up. So from here, what I would encourage you guys to do, once you know your vertex and which way it's opening, or in other words, its general shape, I would stop and I would sketch a graph. Because it's just going to make your life so much easier if you have a picture to go off of rather than just looking at numbers and trying to figure out its max, its min, when it's increasing, when it's decreasing, and all that. So my vertex is at 3, 5. So let's say right about here, and I'm opening up. I really don't care about how stretched or how compressed vertically it is or anything like that. All I care about is which way is it opening and where's my vertex. All right, because trying to sketch the whole thing when we're not asked to is kind of irrelevant for us. I just want a general shape, a general rough sketch of the graph. All right. So the next question I'm being asked is, what's the axis of symmetry? That'll be this line right here. And I see I go right through that x equals 3, x equals 3 point right here. So my axis of symmetry is x equals 3. Now, do I have a minimum or a maximum? I can look at my rough sketch right here, and I can see that this vertex point right here is the smallest point of the whole quadrant. So that means I have a minimum, and that minimum is at y equals 5. I have a minimum at y equals 5. All right? So now we're talking about our domain and set notation. So our domain, I can see that we're always going up and to the right, and up and to the left on both sides of the graph, and do that with forever. So I know I'm going to the left and to the right forever. So that means my domain is going to be all real numbers. Write it however you want to. I'm writing it like this. It really doesn't matter. If you prefer saying negative infinity is less than x, which is less than infinity, go for it. That's fine. It says the exact same thing. As long as you're telling me that it's all real numbers in however way you want, it'll be okay. The range. So for the range, I can see that I have a minimum, and that minimum is at this vertex. So my minimum is at that vertex. That means my smallest y value is the y value of the vertex, which is 5. So I'm at 5, and I go up forever. So I started at 5, and I start going up forever. So that means my range is from 5 to infinity. I'm supposed to put this in set notation, so let's go ahead and try that again. So y, since now y is greater than or equal to 5. It has to be in set notation. If you want to put y is greater than 5, which is less than infinity, or y is greater than or equal to 5, which is less than infinity, that's fine too. As long as you're saying it's every value greater than 5 up to infinity. All right, that's how I'm going to write it. It's probably the easiest and shortest way to write it. All right, now we're asked where is it decreasing and where is it increasing. So remember, we always read graphs from left to right. It's a big mistake I see a lot. Is that you guys don't, sometimes, I don't say you guys, but a lot of people, they read the graph right to left, or from the center to the left, or something like that. You're going to read a graph just like you read a book, left to right. So if we start from the left side of this graph, and we start going to the right, I see that I'm decreasing all the way to this vertex. So from negative infinity up to that h value, which is 3, I'm decreasing. So from negative infinity to 3, I'm decreasing. And then as soon as I hit this vertex point, and I start going to the right, I start increasing. So I'm increasing from the x value of the vertex of 3 to infinity. All right? So that's why it's really useful to have a graph. I think it's most useful, especially for the range decreasing, increasing. It helps you guys see everything that's exactly happening. So I do encourage you guys to draw a graph. It takes you 2 seconds to draw a few lines and, you know, a little U. So please do it. It helps reduce the amount of mistakes you'll make, if you make any. All right. But anyway, go ahead and try B by yourself. Pause the video, try it out on your own. I'm going to go ahead and show the answer right now. And what you should get is this right here. You see that graph is very ugly, but it doesn't need to be pretty. It just needs to do the job. I'm able to tell exactly what my vertex is, if it's a maximum or minimum. I'm able to tell exactly where that maximum is, and I can see where it's increasing and decreasing from that graph. Like I said, it doesn't need to be pretty. It doesn't need to be perfect. It just needs to be able to do the job of what I need it to do. All right, so my vertex, -5, -1 is my HK. My A is negative, so I'm opening down. My axis of symmetry is the line that goes through the vertex at x equals -5, sorry. I see that my vertex is my max, and that happens at y equals -1. My domain in interval notation is from -infinity to +infinity. My range, my highest point now is that vertex at y equals -1. So I go from there all the way down to -infinity. We write our range, or all our intervals really, from least to greatest. So from -infinity to -1, including that -1, is my range. I'm decreasing from -5 up to, I'm decreasing from -5 to infinity, and I'm increasing from -infinity up to -5, right? So the last thing I want to talk about now is multiplying binomials. It's just going to be a quick review. I'm going to show you guys two ways to do it: the box method and just distributing out the terms. Either way is fine. Whatever way you like is okay. So what we're going to do with when we're distributing it is we're going to start with the first term in the first parentheses, and then we're going to distribute it out to every single term in the second parentheses. So x times that first x is x squared. X times 5 is a positive 5x. And then I'm going to keep going down the row of all the terms inside the parentheses. So now in the first parentheses anyway. So the next one I see is that 5, that positive 5. I'll do the same thing, distribute it out. So I get a plus 5x and a plus 25. And I'm out of variables in the first parentheses, so I'm done. All I have to do now is add my terms. And when I do, I get x squared plus 10x. This 5x and this 5x, you can add them together to get 10x. And you add it with 25. And that's your product. The other way to go about this is something called the box method. So what you do is literally draw a box, like the name suggests. And what we're going to do is take each one of these terms and put them on the top. X -3. In the second one, we put on the side x -3. And then we multiply inside the box. So x times x, this x right here is x squared. X times -3 is a -3x. -3 times the first x is a -3x. -3 times -3 is a positive 9. All right? And then from here, you just add like terms. We have x squared, -3x, and -3x combined to give you -6x, then a positive 9. So either way works. Whichever way you like to do is okay. But we're going to keep going. I'm going to leave 3 through 8 for you guys to do on your own, get some more practice with it. The key should be online on Canvas, so you should be able to double check the work from there. Now we're going to talk about squaring binomials. So the one thing I want to talk about here is something I see a lot of students do, and a lot of people, not just students, it's a lot of people in general, is that they try to take this square and they try to distribute it out. X plus 4 squared. So I make a warning, x plus 4 squared, this is not x squared plus 16. You cannot distribute out that squared into each of those terms. That's not correct. X plus 4 all squared is not x squared plus 16. What it is going to be is x plus 4 times x plus 4. When you square something, you're multiplying it with itself. So you have x plus 4 all squared, you're multiplying x plus 4 with x plus 4. And then from here, we're going to do what we did in the previous slide. We're going to take the first term, distribute it out. X times x is x squared. X times 4 is a positive 4x. And then we'll do the same thing with the second term. 4 to x and to 4, so we get plus 4x plus 16. And you add like terms here, you get x squared plus 8x, which comes from these two 4x's. This should be a plus, wasn't very clear. And then plus 16. And that'll be your product when you square x plus 4. All right? Anyway, I'm going to leave 2 through 8 for you guys to do on your own as well. This is the same thing as the previous slide, just with one extra step of knowing with squaring binomials. But anyway, guys, that's the video. I hope it was helpful. And that's going to be it.